So what we're doing now is we're sweeping from 10 megahertz to 50 megahertz in 1 second, and you can see how the amplitude drops as the frequency goes up. Now, why is that? Is that the function generator? No. Actually, what we've got here, here's the function generator. Here's the cable that we're running it into. Look at this. I've got Alligator clips right here going into this Alligator post to BNC. Now, what happens if we change that cable to a straight BNC? Let's take a look. All right, you can see that I've replaced that Alligator clip with a BNC right here. Now let's take a look and see how the amplitude drops under the same conditions. And as you can see, it still does drop, but not nearly as much, which we would expect, given that we no longer have those cables. They're untwisted, and what we had there before is really only good for low frequency. Even at this one, you can see there's a drop in the amplitude, and we will try to characterize that and see how much it drops. But you can clearly see that the cable made a big difference. All right, so we're looking at a sweep from 500 kilohertz to 50 megahertz. You can see the amplitude drops a little bit. That's probably the cable. The cable is a 50 ohm cable. The function generator is set to 50 ohm output. The scope, I think, is at high Z because I haven't found a way to change it to 50 ohms. But I do want to show you, if I go over here, I can get some measurements. And now you can see, let's zoom in here. Now you can see those measurements. You can see the amplitude dropping from about 2 volts per division, about 2 volts. And you can see the high and low dropping. They both drop as the frequency goes up. Okay, so now we've got another cable. This is also a 50 ohm, but instead of being a BNC to BNC, it's a BNC to banana jacks. Now, obviously you wouldn't want to use this for any kind of high frequency work. This is more for connecting a power supply, but it does show you the difference in how you can use that sweep. Now watch this, watch the high and low and see what happens. And we can see the amplitude dropping. It's quite different, but that's again because of the cable, but you can see how it's dropping as the frequency goes up. Let's watch that top there. See what it does. Really didn't drop that much. That's interesting. Now let's look at that peak to peak. Actually, you can just see it. Look how that peak to peak is dropping. You can see that in the peak to peak numbers. We started out over 2 volts, actually more like 2.5 volts. And it drops tremendously. Now all I did, here's what I did. Instead, I just switched the end of the cable. And here's the other end. It made a huge difference having this Alligator clip and going to the post connected to the function generator end rather than to the oscilloscope end. Now let's look at this. All right, watch the amplitude. It grows and then shrinks as we sweep the frequency. See that? See it increase? And then as the frequency gets even higher, it decreases. We've got some resonance going on here. FFT, 20 megahertz center frequency, 10 megahertz per division. Now watch what happens here. Look at that. Looks like we're getting a little folding back, little aliasing problem. Let's see if we can catch that again. Look at that.